In this project, we're dealing with a doodle picture classification task. First, the dataset is a doodle picture dataset which consists of 340 classes. Each class represents a specific scene like a clock or the Great Wall. In each class, we choose 1,000 of them as training set and 500 of them as test set. We transfer each picture to a 32 by 32 dimensional matrix to deal with it. And here is the visualization of our data. Now it comes to the model part. The first model we tried is a multi-class perception mentioned in the lecture. We flatten each image to a vector in order to fit it into it, and the specific structure of it is shown here. Also, we try a deep neural network model, and this model with two hidden layers with it. We also flatten the matrix to a vector to fit into it. Furthermore, we try a state-of-art method called convolutional neural network. We construct two different models with different structures. The first one is shallow and the second one is deep. We construct two different models in order to compare the performance of it. For the perception and neural network, we use gradient descent as an optimizer for it, and for convolutional neural network, we use Adam as an optimizer. For every model, we use cross entropy as a loss function, which is the most popular loss function. Here is the result of our model. We train every model for 20 epochs, and we calculate the loss on training set and classification accuracy on both test set and training set after each epoch. Here is the result of perception. As we can see, the result of perception is not good because it could only receive less than 20% of accuracy on test set, and on the training set, the accuracy is less than 30%. The result of neural network is much better. As we can see, it could receive nearly 100% on the training set and about 40% on the test set. However, it is not good enough. So let's look at the result of convolutional neural network. The shallow convolutional neural network gives a similar result as neural network. It received around 40% accuracy on the test set. However, the deep convolutional neural network, it gives the best result ever. Its performance is much better than the above three method. It received over 50% accuracy on the test set. However, as we can see, it still missed some problem, like the result is not that good, and it made something like overfitting. So we tried two different tricks in order to improve the result of it. First, the batch normalization. Batch normalization is a neural network version of data normalization mentioned in the course. We add the batch normalization to the deep convolutional neural network model, and result of it is shown here. The accuracy improves a lot. It could receive over 56% of accuracy on the test set, and it receives over 60% after around 10 epochs. But as we can see, it still missed some problem like overfitting. So we tried another trick called dropout. Dropout is a useful way to overcome overfitting in neural network, and we add dropout layers to the deep convolutional neural network model. Here is the result of it. It receives the best result. The accuracy on test set is over 60%, and it effectively overcomes the overfitting. So finally, we add both the batch normalization and dropout to our deep CNN model, and the structure of it is shown here. And as we expect, it receives the best result. It receives over 65% of accuracy on test set. And thank you. Here is the representation of our project.